Hi, everyone. My name is Toshio Kuratomi. I'm A Badger 1999 on IRC and Matrix. Toshio at fedoraproject.org for email and external chat. And I'm going to give you a short talk today on Un-Googlable Python features. Just set this up to present. Okay. Un-Googlable Python features. The goal of this talk is to, give you enough of an overview that when you see these features in someone else's Python code, when you read it, you'll be able to recognize them, and to give you these search terms so that you're able to Google for them later, because I might not explain it very well, or you might find that you've forgotten what I said by the time you actually read it somewhere else. Okay. So these are the 5 features: Python's for-else, the ternary expression, slice notation, list comprehensions, and generator expressions. So let's start with for-else. In Python, there's this unique feature called for-else. It's not that common in other languages. What it allows you to do is to do something if you do not break out of a for loop. And in other languages, like I said, they don't have for-else. So usually in other languages, you'll implement this with a flag variable. So what is a flag variable in this case? Well, here's a little example. We have a list of paths: user share, etc., user local share, user local, etc., in the current working directory. And then we set a flag variable, path underscore found equals false. All right. And then we have a for loop for path and paths. So we're looping over our list of paths. And what are we doing with it? We have a condition inside the for loop. We're checking to see if the path plus convert to rel exists. So we're looking for this convert to rel directory inside of this for loop. If we find it, then we set path underscore found equal to true. We change the flag variable to true, and we break out of the loop because, hey, we found a directory. We don't need to do anything further. If we do not find it, then we go to the next path, etc., next path, user local share, next path, user local, etc., next path, current working directory. Each of these cases, we check to see if that path exists, and if we're continuously finding that they don't exist. Eventually, we get to the end of our paths, and we drop off the end of the for loop, and path underscore found is still false because that's what we set it to originally. Okay. Then, once we're out of the for loop, we check if not path found, raise IO error. So we're saying, okay, we're going to check all of these paths for the convert to rel directory. If it's not found, then we have to raise an error because we need that directory for something. And if it was found, then we're okay. We'll continue on with our code and do whatever. So this flag variable is being set inside of the for loop to flag that we found the path. Otherwise, when we got out of the loop, we wouldn't know if we found the path or not. So here's how we do it with a for-else. You see, we still have the same data, the same paths list. We still have the same loop for path and paths. We still are doing the same condition check if os.path exists. But now we don't have a flag variable. We don't have to set anything. We just break out of it once we find that one of these paths exists. So what does this mean? Well, you can see that as we're doing this, we're going through, we're looping. And if we find it, we break out. And when we break out, we actually go all the way down below that else to whatever our next code is. But if we don't break out, if we go through user share, etc., user local share, user local, etc., in the current working directory, none of those satisfy the conditions. We never break out, and we end up just naturally dropping off the end of the for loop because we've exhausted all the paths. That's when we get to the else statement. And you see the else is indented to the same level as the for. So it's the for and the else go together, not the if and the else. So the for and the else go together, and it says, okay, we dropped off the end. That means that we did not find convert to rel directory in any of these paths. Now we're going to raise IO error. No convert to rel data directory was found. So it's a simpler, more concise way to write the same thing as this. We don't have this extra flag variable that we have to hold on to. We can omit 2 lines and hopefully write something that's easier for people to understand if they understand what for else does. The next thing is the ternary expression. Lots of languages do have ternary expressions. It's a way to write on a single line an if then else statement. And it's commonly used to conditionally set a variable to a value or to a default value. So let's see. Here's how you would do it without the ternary expression. If btrfs is in file systems, then we're going to set this one variable fs format opt equal to -- format equals btrfs. Else we'll set it to a default value, fs format opt equals -- format equals ext4. Okay, so we have all the conditions that make for a good ternary expression here. We have a simple condition. We have a variable that we're setting to one value if the condition is true. Otherwise, we're setting it to a default value. This is how we write it as a ternary expression. And if you wanted to read that aloud in English, you'd say, okay, we're going to set fs format opt equal to -- format equals btrfs if btrfs is in file systems. Else, we're going to set it to the default -- format equals ext4. The ternary expression is very useful in simple cases like this, where you have a simple condition and a simple value to set it to. If it was a lot more complex, like say you had 3 different conditions that you were trying to find out if it's satisfied, I would probably not use a ternary expression because I think it would become unreadable. Doing it on one line is nice, but the goal should always be to write readable code. And if you have a lot of conditions, then doing it in multiple lines like this with a regular for loop, regular if statement is better than trying to put it all on one line with a ternary expression. Next, we have slice notation. Slice notation is an efficient way to take a subset of a list, string, or other sequence. So, if you have a list that is contains 1, 2, 3, 4, 5, and you say, oh, I want to take the last 2 elements of the list, you can use slice notation to take the last 2 elements or the first 2 elements or any 2 elements in there. The offsets for slice notation point between the elements of the sequence. So what do I mean by that? Let's take a look at our example. Here we have my list equals A, B, C, and D. And if if you've used lists before in any language, you're probably familiar with the idea that, okay, each of these elements in the list has an index number. So A is index 0. If I do my list bracket 0, then I'm going to get A back. If I do my list bracket 1, then I'll get B. If I do my list bracket C, I'll get my list bracket 2, I'll get C. My list bracket 3, I'll get D. So that's how you do it when you're just getting a single value back, extracting a value from the list. But if you're doing a slice, then you're actually getting a list back, a subset, a sublist of the list that you have. And when you do that, it's easier to think of the indexes as pointing between the letters. So 0 points before the A, 1 points between the A and the B, 2 points between B and C, 3 points between C and D. Let's see this in action so that maybe it'll be a little bit easier to understand. We're going to print my list bracket 0:1 end bracket. So 0:1 is slice notation. It's not saying give me element 0. It's not saying give me element 1. It's saying make me a list that consists of all the elements between 0 and 1. And if you remember, if you look at my little comment up there, you're saying, okay, 0 points before A, 1 points after A. So this is going to return a list with A inside of it. Okay, so that's how you get a 1-element list out of this using slice notation. A 2-element list, okay, well, we're going to use my list bracket 0:2, and the 0 points before the A, the 2 points after the B. So what we get returned is a list with A and B inside of it. Now there are some handy shortcuts here. You don't have to specify 0 if you want to start at the beginning of the list. So say I want the first 2 elements of the list. You can write it as my list bracket 2 end bracket. No 0 at the front, but Python says, okay, you didn't specify that. it means that you want the beginning of the list up to the element 2. And so it will return a list with A and B in it, just like when we specified 0:2. What about the end of the list? You can do that. You just specify mylist bracket 2: end bracket. You're not specifying the endpoint. So Python's going to say, okay, go from the second element all the way to the end, and that's going to be C to D. Now you might think, okay, well, I specified 2 in both of the last 2 examples here, but in the first one it went A to B, and the second one it did C to D. Why isn't B in both of them? Well, remember, these indexes are not pointing directly at the elements in the list, they're pointing between them. So if you look at the diagram, okay, where does 2 fit? 2 fits between B and C. So when we're specifying it as the endpoint, mylist bracket 2, that's the endpoint, then we're going up to that, so it's A, B. But when we're specifying it as the beginning point, mylist 2: then that's the beginning point. It falls after the B and before the C, so we're doing CD. Offsets don't have to be from the beginning of the sequence. They can also be from the end of the sequence. So here I've redone my comment that shows where each of these indexes falls using negative offsets instead of positive offsets. So we use a negative number to say we're going to start counting from the back of the list. And so we have A, B, C, D, and we see, okay, -1 falls between C and D, -2 falls between B and C, -3 falls between A and B, -4 falls before the A. All right, so I want to do I want a subset of my list, and it's whatever falls between -2 and -1. Okay, well, that will be a list with a single element C. Well, if -1 is falling between C and D, how do I specify to go to the end of the list? Well, remember from our previous example that we could specify the end of the list with just colon and then nothing after it. So that's what we're going to do here. We're going to go from -2 to colon nothing. And so then Python will say, okay, so I'm going to start with 2 elements back from the end, and I'm going all the way to the end of the list. So 2 elements back from the end is C, and there's also D before you get to the end of the list. So Python will print C and D. Okay, so that's slice notation. There's one other thing you can do with it, and that's make a copy of a sequence. So I kind of glossed over this, but each of these slices is actually a copy of a portion of the list, right? So when we did, well, let's say my list bracket -2 end bracket, that's saying, okay, create a new list, and inside of that list have the elements from my list that were at the -2 position through the end of the list. And so that's C and D. So the C and D there are inside of another list. You have my list, and you have this new temporary list, which we printed. So to make a copy, we can make a copy of the entire list if we want to by specifying no beginning point and no end point. So my list bracket end bracket is going to say, okay, I want the slice of the list that is the whole list, which is I'm going to make a new list. I'm going to populate it with all the elements that were in my list. So this will print list A, B, C, D, and list, because we have made a copy of the complete thing. And let's just prove this to ourselves. So my copy equals my list bracket end bracket. Okay, we think we have a copy in my list. When we print my list equals my copy, it prints true. And that's because all of the elements of my list, all the elements of my copy are the same. So they are equivalent. They are equal when you use the double equal sign. But if we print the ID of my list and the ID of my copy, we see that they have different IDs. And that's because they're different objects. They're different instances of lists that just happen to contain the same thing. So when we print my list is my copy, is the way that we prove identity in Python. It prints false because just like ID showed us, these are different instances of list. They contain the same things, but they are different objects. And this means that if I did my copy.append E, for instance, my list would remain A, B, C, D, but my copy would have A, B, C, D, E, because I appended to the copy I didn't append to the original list. Okay, list comprehensions. List comprehensions are an efficient and compact way to write a for loop. They're useful for transforming and filtering lists. So efficient and compact. There are two things contained in this idea. The for loop is going to be compact because you can take a for loop, which is several lines, and you can put it into a single line. So it's takes up less space in your code. If people understand list comprehensions, then they'll be able to get more information in that one line than having to read over several lines. So hopefully they'll be able to get it faster. It's also efficient because a for loop itself has to be evaluated by the Python interpreter, whereas a list comprehension, Python is able to take the list comprehension and hand it to some portion of Python written in C and execute all of that list comprehension in C code. So it's going to run a lot faster than writing the for loop out altogether. Useful for transforming and filtering lists. Let me give you an example to explain what that means. So here's a for loop where we're doing some filtering and transformation. We start with my list equals 1, 2, 4, 50, and 1000. We create a variable filtered and doubled, which is an empty list. We're going to stick our transformed and filtered list into this variable. And then how do we build it up? Okay, we're going to use a for loop for num in my list. We're going to iterate through my list. Every time through, we're going to check if the number is less than 10. And if so, we're going to multiply that by 2 and append it to filtered and doubled. So the first time through, 1 times 2 is 2. We're going to append that to filtered and doubled. It'll be a list with 2 in it. Then second time, we're going to get 2. 2 is less than 10. We're going to double it. We're going to get 4. Filtered and doubled will now have 2 and 4 in it. Third time through, 4. 4 is less than 10. Double it. Now the list is going to be 2, 4, 8. The next time through, 50. 50 is not less than 10. We're going to skip that. Next time through, 1000. 1000 is not less than 10. We're going to skip that. Okay, and now we've reached the end of the list. Filtered and doubled now contains 2, 4, and 8. So this is the for loop way of writing what we're going to do with the list comprehension. Here's the list comprehension. You see we reduced that whole for loop down to just a single line. Syntax-wise, it starts with the square bracket, just like a list does. So you can kind of think in your head, list comprehensions create a list. So I'm going to use the square bracket, just like if I was creating a literal list. And then you see the various parts of our list embedded in this list comprehension. And I'll just kind of flip back and forth here to show you. This 2 times num is the transformation that we're doing near the end. We're going to take num times 2. Every time through here, we're going to double the number. But where are we getting number from? Oh, 2 times num 4, num in my list. Okay, so this looks just like the list portion of what we did before for num in my list. So that's telling us the same thing. We're going to loop through my list, and for every element in there, we're going to set num equal to that element, and then we're going to multiply it by 2, right? Well, there's one more thing in here, and that's the filtering section. If num is less than 10. So this is specifying a condition. And just like in our for loop where we said if num is less than 10, then we're going to do something with this. Otherwise, we're going to eliminate it from the list that results. Right here, we're saying if num is less than 10. So for 1, 2, and 4, it'll be less than 10. We're going to multiply it by 2. But if it's greater than 10, we're going to discard it. It will not be in the list that we create at the end. Okay, so just going through. First time through for num in my list, what is the first number? It's 1. 1 is less than 10, so multiply it by 2. 2. Second time through, it's 2. 2 is less than 10, multiply it by 2. It's 4. Third time, 4 is less than 10, multiply by 2. It's 8. 50, greater than 10, discard it. 1000, greater than 10, discard it. We end up with a list at the end that is 2, 4, 8. So it's going to be exactly the same as doing it with a for loop. If it's very simple like this, you have a very simple transformation, you have a very simple condition, list comprehensions can be more readable. But again, if you had multiple conditions, or you had a very complex transformation that you were doing, it might be better to write this all out as a longer list for loop rather than using a list comprehension. Or you can use generator expressions. So what are generator expressions? They're just like a list comprehension, except it only iterates. It doesn't create a list. So what do I mean by that? Let's look at our example. Here we have my list equals 1, 2, 4, 50, and 1000, just like before. Filtered and doubled equals something that looks very much like our list comprehension, except it uses parentheses instead of square brackets. So remember, square brackets look just like a literal list. So, hey, that's a list comprehension. But these parentheses are what introduces a generator expression. Other than that, the syntax inside is the same as for the list comprehension. Okay, so far so good. It's very similar. Well, what's the difference? Let's iterate through our generator expression and see what happens. For number and filtered and doubled, we're going to go through, and the first thing to note is that this is done when elements are accessed from generator expressions. So when we set filtered and doubled equals parentheses 2 times num for num in my list if num is less than 10, that is setting up a generator. It doesn't actually process my list yet. It just says, okay, I am ready to process my list. When you tell me to, I'm going to go through my list and I'm going to perform these operations on it and give you an answer one at a time, one for each element in my list. Okay, so here we are going to actually do that. We're going to use this for loop for number in filtered and doubled, and we are actually going to go through and say, okay, I'm ready now. Give me the first element. So filtered and doubled says, okay, well, I need to get my first element from my list. That's the number 1. It's less than 10. 2 times 1 is 2. It gives us 2. So now number equals 2. We print it, 2. Okay, second time through, we ask filtered and doubled for the next number. It says, okay, what's the next number from my list? 2. Okay, it's less than 10. 2 times 2 is 4. That gets printed. And next time through, 4. 4 is less than 10. 4 times 2 is 8. Okay, we're going to print that. Then 50. Oh, 50 is greater than 10. Omit it. Oh, 1,000 is greater than 10. Omit it. Okay, I'm at the end. I'm done. I've got no more numbers to give you. So now the for loop says, okay, I'm done. I have no more numbers to set here. And so then it falls off the end of the for loop. Okay, so far so good. This does exactly the same thing we would have thought would happen with the list comprehension or a list that just specified 2, 4, and 8. Okay, so far it makes sense. Now we're going to do a second for loop for number and filtered and doubled, print number again. This time it prints nothing. And the reason is that we created a generator which is going to iterate through my list once. And it's going to find those values when we use them, and it's going to give them to us. And then after that's done, it has nothing left to do. So it's going to say, I'm already exhausted. I've already run through my list, given you answers for every single thing in it. I have nothing left to do. This is different from the list comprehension because the list comprehension actually creates a list. And so when you define up here, filtered and doubled equals to this list comprehension, it's going to run through my list. It's going to figure out, okay, 3 of these values are relevant and 2 of them got filtered out. Those 3 values that are left, multiply them by 2. Okay, so now I have filtered and doubled equals a list, 2, 4, and 8. And you can consult that list over and over and over again multiple times, and it's always going to be 2, 4, 8. So if you put that in a for loop the first time, you'll go, okay, 2, 4, and 8. A second time, you'll start from the beginning and go 2, 4, and 8. But the generator expression, it doesn't create this intermediate list, and it's just going to run through what it was given, the data it was given once. So the second time you run this for loop, it's already done all of its work. It has nothing more to do. You can take generator expressions and combine them like shell pipelines. So if you look, maybe we decided that it was too complex for us to do both the filtering and the transformation in one step. So for readability, we want to do it in 2 steps. So here we have mylist the data, filtered equals num for num in mylist if num is less than 10. You see that generator expression just has the filter in it if num is less than 10. And then doubled equals the generator expression 2 times num for num and filtered. So here we're doing the transformation 2 times num. And where are we getting num from here? Oh, we're getting it from filtered, right? So we're stacking these just like a shell pipeline, right? My data is mylist. The first piece of this shell pipeline would be filtered, where we're going to filter out less than 10. Then the second step of the pipeline is doubling it 2 times num for every element in there. Okay, so putting it together, when we run our for loop for number and doubled, we're taking the last portion of our pipeline, and we say, okay, doubled, I'm ready for my first number. Doubled says, okay, where am I getting my number from? I'm getting it from filtered. Filtered, what's the first number? Filtered says, where am I getting my number from? My list. What's that number? 1. Okay, and I'm filtering it. Is it less than 10? Yes. Okay, doubled, here's 1. Doubled says, okay, I've got 1. Multiply it by 2. Okay, it's 2. For loop, here's 2. The for loop takes 2, sets number to 2, prints it out. There's 2. For loop says, okay, doubled, I'm ready for my next number. Doubled says, okay, filtered, I'm ready for my next number. Filtered says, okay, my list, next number is 2. That's less than 10, pass it back to doubled. Doubled multiplies it by 2, passes it to the for loop. For loop prints 4. Asks doubled for the next number. Doubled says, filtered, give me your next number. Filtered says, okay, well, that's 4. Doubled gets 4, multiplies it by 2. The for loop gets 8, prints that out. Says, okay, doubled, give me your next number. Doubled says, filtered, give me your next number. Filtered says, my list, next number, 50. Oh, that's less than 10. Nope, not going to pass that one back. Next number, 1000. That's not less than 10. Not going to pass that one back. Oh, I'm done. Filtered tells doubled, I'm done. Doubled says, oh, well, then I'm done too. It tells the for loop, I'm done. For loop says it's done, and it drops off the end. Okay, so that's pretty simple, right? Why would you want to consider this, though? Why is a generator expression better than a list comprehension? Well, it's very useful when you're optimizing for memory usage. So let's take an example. Here we're going to open a very large file. Let's say that var log messages contains 2 gigabytes of data. We probably don't want to read all 2 gigabytes of data into memory at one time. But if we were doing this with list comprehensions, remember it's creating a list at every step of the way. So if we did this as list comprehensions, we'd first open var log messages. We'd then read in all of var log messages into this from DNF variable. And we're filtering it to make sure that DNF is in the string. We only considering messages that are from DNF. So then from DNF would be a list that would contain all of those messages, some subset of the 2 gigabytes. Oh, then we want to filter it by things that were happening on February 8th. So then we have the second list. If this was a list comprehension, we'd have a second list here that got created with the subset that was of February 8th. And then we want to transform it. We want to remove the new lines, so we strip the new line off. So then we'd end up with the same number of lines, but with one less character in each line. And then we say, okay, message only. We only want the message portion, what comes after DNF, not what comes before. Okay, so then again, we have all those same lines with the front portion removed. Okay, so now we have 4 lists that we have to keep in memory out of this 2 gig file that we started with. Some subset of that is going to be in each of these 4 lists. We're repeating this data over and over again. If say half of the lines in var log messages had to do with DNF, we could end up with not just 1 gig of data, but more than 1 gig of data because, okay, half of it was saved in from DNF, but some of that half was still saved in on date, and some of it was saved in no new line, and some of it was saved in message only. Generator expressions, like we're doing here, allow us to optimize all that memory usage away. When we do the for loop at the end, this sequence of generator expressions will ask for 1 line, right? Message only asks for 1 line from no new line. No new line asks for its line from on date. On date asks for its line from DNF. From DNF is getting a single line from the file handle. So at any given time, we are only processing one line in memory. And that means that we don't have the problem of reading the entire file into memory and having to, process all of that at one time. We're only dealing with one line. The memory usage is much smaller. So this has been my presentation. And like I said, I want you to be able to Google for these features later. So here's that slide again, 5 features that occur in Python. The Python 4else, ternary expression, slice notation, list comprehensions, and generator expressions. Okay. Thank you very much for attending. I hope that you learned something from this, and I'll see you next time. Okay, I'm going to turn off recording here somehow.